Okay, thanks for your patience, everyone. I hope you enjoyed morning tea. Next up, we have Azul, who will be presenting about LLMs and foundation models. She'll be presenting from online, and we've got her on Zoom now. So let me switch over. Okay, we can see you and hear you, I hope. Go ahead, Azul. Take it away.
Thank you so much. Hello, everyone. I'm very happy to be here and very grateful. I'm Azul, and today I'm going to talk about some ideas around generative AI for forecasting agents. But before that, this weekend is very important because it's Pride Weekend, and in that weekend we celebrate diversity and we show our pride. And I think it's also a good opportunity to celebrate the most important thing in life, which I think is love. So if you need to hear this, you are valid, you are enough, and you are loved. Moving on to other things, and having said that, yesterday there were some conversations around R and Python and what's the possible future for both programming languages in the forecasting space. And I kept thinking that humans communicate differently. And that maybe the answer about forecasting software is in another place. And I remember this tweet by Andres Carpati saying that the hottest new programming language is English. And he was referring to this whole wave around large language models. But does this apply to forecasting? And I think the answer is not before, until now. June 26th, 2025. I'm very happy to introduce you all to Time to Pilot, the Gen AI forecasting agents, where large language models meet foundational time series model and other models, other time series models in general. But before that, let's ask some questions. What's all this hype around AI agents? Because we can see in news, in LinkedIn, in Blue Sky, a lot of conversations around AI agents. And these agents are trending across domains. We can see them in code development, in research, in chat and productivity, and web and browsing, enterprise workflows, as multimodal assistants. And if we look at the searches for AI agents as a time series, we can see that there is a clear trend upwards. And agents are everywhere. We can see them, for example, through GitHub Copilot, GPTs as autonomous task runners, Gemini CLI that was recently launched just a couple of days ago, AutoGPT, Baby AGI, Devin. And this agentic era, these AI agents, this agent wave will only grow. But let's start with first principles, just to establish a common ground. What is an AI agent? I really like this image by Google, which defines an agent based at the beginning by a user query. So we want to achieve a goal, and we can write down this goal as a text with natural language. So an agent basically is a combination of three things: a large language model, which is indicated by pink, the orchestration routine, which is indicated by green, and a set of tools indicated by orange. So the agent runtime basically defines the goal of the AI agent, the task that it wants to solve, and also the rules that will apply to it. And the memory also plays an important role. What's happening right now? What's happening in the decision making for the agent, for the LLM in the particular moment? But also it can have, as we all know, long-term memory, what the agent already knows about the user. And based on that, it can reason and it can plan. It can think through what to do next. The model, basically, it's the brain. It's usually a large language model doing the heavy thinking. It decides what to do next and which tools to use to solve that particular goal. The tools are simply external helpers. We can think them as functions, APIs, or models, other large language models that will help the LLM to get things done. For example, it can be a forecast function, upload function, and an explain model function. I really like this simple definition by Langchain. An AI agent is a system that uses an LLM to decide the control flow of the application. So basically, an AI agent is an LLM which can have also tools. Sorry, I got confused by the chat. Yeah, so basically an LLM that has tools. We can think them with a mathematical intuition. It's simply a for loop. The LLM observes the environment. It reasons based on that environment and the context that it has. And based on that, it can choose the best action. Once the action is done, it will update the state, the environment, and it will repeat this process until the goal is reached. So basically, an agent is a combination of planning, tool usage, and feedback. And agents are increasing their presence across modalities. If we take a look at the recent research, we can see that they are available in the image modality. They are helping to caption an image, to editing image, to generate image, to segment image. They are also being applied in text, for example, retrieving knowledge. Also, it has a lot of applications, as we all know, in code generation. They also have been applied to video through video editing, object tracking, and also in audio to speech to text and text to speech applications. But where are the forecasting agents? What's happening in our field? And I think this question is very important because forecasting has an impact. It requires a lot of technical knowledge, and it's widely needed by a lot of companies and practitioners all over the world. But so far, there's been little agent-based experimentation in the field. And it's a perfect fit because, as we all know, it requires a lot of different steps: model selection, error diagnosis, data cleaning, code generation. So I think there is a good opportunity to use open source and to create something open source to experiment. Right now, there is a current focus on language, vision, and robotics, and time series is often underhyped. And what is very interesting is that we already have the tools. We have time series foundational models. We have open source tools, for example, by Nixla. We have BlueONTS. We have SKTime. We have the whole R ecosystem. We have LangChain to orchestrate agents. We have large language models by OpenAI, Claude, Mistral, among others. So why forecasting needs agents and why now? So I think the answer is that forecasting is complex and messy. You need to decide a lot of different things. You need to decide which model to use. You need to decide if you want to calculate features or not, if you want to analyze the data or not. And agents can make this all complexity and messiness navigable and human-friendly because you only need to use natural language to interact with them. And also, I think now it's a good opportunity because no one's have cracked this shit. And also, I think they give the opportunity to use the strengths of the forecasting community, to use different programming languages, to use the different implementations of the different algorithms that we already have. And there is a lot of documentation. There is a lot of textual context that we can ingest in the large language models, in particular for forecasting tasks, to improve how the AI agents can behave and solve particular problems. So let's go live with Time Copilot. Time Copilot is the Gen AI forecasting agents. It's a playground where LLMs meet foundation time series models and in general time series. You can go to the GitHub repo, and if you like the project, please give it a star. And also, you can go to the official documentation at timecopilot.tech. So before doing a demo, let me explain how it works. So Time Copilot is a generative agent that follows a systematic approach to forecasting. And it follows the following diagram. It starts with time series data. Then it performs feature analysis. It calculates different features. It decides based on intuitions of the time series data which features to use, which features to compute. This is one of the first decisions that the LLM is making. Then based on those features, it analyzes patterns and also it generates insights. Then it performs model selection. Based on those feature insights, it decides which models to evaluate in the next step. So it can select the different models from a list of predefined models. It can select, for example, arithma, if it sees that it can fit well to the time series data based on the previous calculated features and the previous generated insights, but also it can select a foundational time series model. Performing cross-validation, it selects the best model, and once it has the best model selected, it generates the forecast. It analyzes the results and it explains insights based on those results. So this agent uses LLMs to interpret these statistical features and patterns of the time series data. The LLMs guide the model selection based on these data characteristics and features, and it explains technical decisions in natural language. And also it can answer domain-specific questions about forecasts. Let me show you an example of a time copilot. So yesterday, Rob showed the book Forecasting Principles and Practices, the Pythonic Way, that we released some weeks ago. And it has some data that we can use to perform some analysis. So let me copy the classic air passengers. I just want to copy the link address. I don't want to download the data to show how you can use Time Copilot. So I'm gonna just have a first glance of the data. I just want to show you the structure that it has. In this case, we have just two columns, the column that defines the timestamps of the time series and also the target value that we want to forecast. And what I think is pretty cool about Time Copilot is that without downloading the data, without running any Python script, without having anything in the current directory, let me show you. You can generate and analyze this particular data set. Let me show you how you can use that. You just need to call Time Copilot Forecast using UV, which is a Python manager, which is amazing, by the way. Then you can call Time Copilot with the forecast instruction. You just need to pass the data that you want to forecast. And as we all know, there are different large language models available. For this particular example, let's use OpenAI GPT-4o, which it's interesting to use. And let's see what happens. So in this moment, the agent is running. It's calculating the features. Based on the features, it's performing cross-validation. And then it's gonna be analyzing the results of cross-validation. I'm gonna run it again. I think there was a problem with the output. In a moment, I'm gonna show you what is happening behind the scenes, just for you to have a better idea of how Time Copilot is designed and the decisions behind it. And I can show you a little bit how the results are there. So this is the output of Time Copilot. So in this case, Time Copilot selected theta as the best forecasting method. It selected these features just to have a glance of the time series. It created this feature analysis. So it, for example, says that the series exhibits a strong trend, and it explains in natural language the features, the calculated features. It also provides model information about the selection of the model. So, for example, it explains what the theta model is. It explains what is the rationale behind the selection of the theta model. It provides the comparison of the different models that it tested. It also offers a performance analysis of those cross-validation results. And finally, it offers the forecasting results as a data frame, and also it provides an analysis of the forecasts. And Time Copilot was able to do this without downloading any file, without running any Python script, just with one line of code. But these are LLMs, and we want to chat with them. So we want to ask questions about the future. How can we do that? So let me export some environment variables. You don't need to export these variables to chat about the future with Time Copilot, but they are going to help us to see what's happening behind the scenes, because a Time Copilot has logger integrated that we can analyze later. So how you can chat about the future with these LLMs? You just need to add the prompt parameter, and you can start asking questions about the future. For example, I can ask how many passengers are expected in total in the next 12 months. So I just passed the data set, the large language model I want to use and the question I want to solve based on the forecasts that are being generated. So to see what's happening behind the scenes, Time Copilot has this integrated logger, and we can see all the steps that the agent is taking. Here, for example, in the first prompt, here is the series that has been passed to the context, the PS features calculated, the model that was selected, the forecast, and I think it's complete now. So the total expected number of passengers in the next 12 months is approximately 6,000. So we have an answer of the query that we just wrote. And this was an example just using the CLI. But what happens if we want to interact with these results on a lower level? For example, you would like to, I don't know, maybe parse the response of the LLM to decide what to do next, or even create your own forecasting agents for particular forecasting tasks, or even get the forecast to analyze them in a different manner. So you can do that using Python. So for this particular example, I'm going to be using Beam, but of course you can use any IDE of your preference. In this case, I'm going to be using Beam through Cursor. So the first thing you need to do is to import the libraries. In this case, I'm going to import pandas for reading the data. And I'm going to import Time Copilot from the Time Copilot library. I'm going to read the data. In this case, I downloaded the air passengers data before. And we can define the forecasting agent with the Time Copilot class. And we can select the LLM that we want to use using the model argument of the Time Copilot class. In this case, I'm going to use GPT-4o. And then we can generate the forecast using the forecast method of the forecasting agent instantiated class. To add the prompt, we just need to use the prompt argument. And I'm going to ask the same question. So then I'm going to print the forecast generated by the pipeline. And also, I'm going to print the answer of the LLM. And here is an output. User prompt response. And obviously, if you want to add different steps or other steps, you can do this. Basically, you can create more commands here based on the forecast. You can plot the forecast and so on. But here the agent is running, and hopefully, if it doesn't start to hallucinate, we will have results soon. Here is processing the whole workflow. And as you can see, you have the forecast generated by the best method, and you also have the response to the prompt. So you can start creating workflows with these results using Time Copilot. So if you are creating a dashboard, or you are doing a business intelligence analysis in which you need for a user to pass queries using natural language, you can use the forecasting. You can use time copilot. So what's next for time copilot? The first thing I need to do is to add more tests, because as you saw in the first example, it requires more work on the testing side. There's also a roadmap that it's documented here. Basically, adding multi-series support, processing for multiple series, cross-series analysis for those multiple series, hierarchical forecasting, advanced model integration, for example, how you can register your own model. And it opens the door to a complete set of exciting new features. For example, an anomaly detection agent where you can ask the LLM to detect anomalies, to perform some analysis based on those anomalies if you want to remove them or you want to impute those anomalies with a different value. And also the opportunity to perform root cause analysis, alert generation, and also it offers the possibility to create multi-agent systems where you can create, for example, collaborative forecasting. One agent can select models, but the other one can select a different model, and they can start collaborating, and they can even ensemble predictions. And you can also have forecasting agents specialized in different applications. And also in the roadmap is a plan for enhanced capabilities, for example, exogenous variable support, that it also opens the door to, for example, a causal analysis. In the roadmap, there's also the API development project to expose Time Copilot as a possible API. And there is work to be done in the infrastructure and the developer tools, the CLI improvements, Jupyter integration, more examples, and so on. So for the next steps, try Time Copilot. It's in an alpha stage right now. So if you try it out, it's going to be very valuable, because it will help us to detect early bugs. You can also, there's also a Discord for community support. If you want to join it, it will be amazing. You can share your cases, feedback, design things that you want to share. And also, if you want to contribute, please go ahead. There are open issues there. There are items in the roadmap that are very interesting. Submit feature requests, something that you would like to see. If you encounter a bug, please submit it. Also, there's a lot of work to be done in improving the documentation. And just stay updated, start the repository if you like the project, join the Discord community, watch for new releases, be happy. And that's my presentation. Thank you so much.
Thank you, Azul. I'm going to feed it over to the first question.
Hi, Azul. Can you hear me? Should that come?
Yes, I can hear you.
Perfect. Okay. Thanks for the presentation and the very interesting demonstration. I have a couple of questions, more philosophical, and then I have more technical ones if we have some time. So the first one is, you had on your early slides that about the differences between the languages and that we communicate with language. Yes, I agree. And that's why LLMs are great. And that's why they have been added in our lives. But forecasting is, like, in my view, at least, a different task. And we know that judgmental predictions add bias and add literature on that and otherism. So why should I drop my models that I use in the first place to remove this bias and add a jumping environment that will add extra bias. That, in my view, that adds an extra layer of uncertainty on top of what we already have. So what's the motivation? Like, how would you persuade a person to, like an expert, like a forecasting expert, to drop his models and go somewhere that will introduce extra uncertainty in his predictions? Like, even the forecast analysis and the model selection, like, it's extra uncertainty there. So what's your motivation? How do you view that?
Let me ask you with another question. Why do you think it adds extra uncertainty? I would like to hear your thought process.
Sorry,
on that.
Could you repeat that? You dropped a little bit. Could you repeat that, Azul?
Yeah. Why do you think it adds another layer of uncertainty?
Well, because these, and you have the examples like the auto GPTs and the baby AGIs, like they are unstable at the moment. They don't work so great. So, okay, excluding Gemini CLI, which is for a different tasks. So they add uncertainty because they are not working so well, and they make decisions, and these decisions are uncertainty. So where there is a decision, there is uncertainty. So why should we add that layer of complexity? That's it's philosophical. It's open. There's no thing. I might agree with you, but I just want to hear your point of view here.
Yeah, that's a very good question. Thanks for the clarification. And yeah, I agree. I mean, there is a lot of concerns on how agents and LLMs take decisions, and I think it's not by itself a problem of how to apply a LLM agentic design to forecasting, but it's a problem that all agents are facing, the AI agents. And I think we have seen that there is a lot of research on the direction on create more stable agents and to reduce their uncertainty. And as I see in particular Copilot, it's that it can add a new level of uncertainty, but that extra level of uncertainty in some way can also be quantified because we can know exactly the process and the decisions that the agent is making. It's not a complete uncertainty in the sense that we don't know what's happening behind the scenes. We exactly know which decisions the LLM is taking. For example, one of the decisions is which features to use. And if you think about it, at the end of the day, it's a decision that we as a forecasters make when we are modeling time series. So in some way, it's a level of uncertainty that we as a practitioners also add to the workflow that we are designing. Why we decide to use this feature instead of this other feature. And if you think about it, at the end of the day, I think it's also it's a level of uncertainty that we add to the forecasting workflow. For example, which library to use, no? And what is doing Time Copilot is to automate that kind of decision using context, using particular context, no? So that would be my answer. Yeah.
Oh yeah, thanks. That's a good pass for my second question. Actually, first of all, thanks for the answer. So most AI tools that are that work very well is where there are interactions between human and the tool. Like you can see Corso, you can see all these other windsurf and so on. And based on what you said, so it's a human will typically want to make a decision. We are like this humanistic point of view where we want to make the decision. So I don't want to leave the AI to make the decision. So how can you how can we take the tool that you have designed, which is great actually, and improve it and make it more interactive? So instead of the AI making the decision, which adds the uncertainty, I will make the decision and it will suggest. So you see where I'm going? Instead of making decisions, making suggestions, and I make the decision. So that reduces uncertainty. Like, what's your roadmap on that? Do you have that in mind? Anything, any views on that?
I love that question, and I think it's very important, and it's a very exciting feature. And absolutely, I think it's the next step because, as you mentioned, we want to interact with Time Copilot in a deeper level. So one thing that I'm thinking of, for example, is that, for example, in this particular step, the LLM can propose the features that it wants to calculate, but the user decides if it will calculate those features or not. Or for example, once the insights are generated, the user can provide feedback on those insights before going to the model selection step to also inform with the user expertise the model selection. So definitely, thanks for bringing that question up.
Yeah. Okay. I have more, but I'll leave other people ask questions as well. Yeah. Yeah, please, guys.
Hi, Azul.
This is Reza.
Yeah, it's Rasu. And you in this diagram, you're describing a machine learning pipeline, and why I should pass a machine learning pipeline to an ML, which I would need millions of dollars to train, and where it's just a machine learning pipeline. I can also derive my features, cross-validate, and then based on an error metric, select the best model. And what would be the advantage of that? Because in the end, I would be even dependent on, I don't know, ChatGPT or OpenAI or other LLM. Why I should bring extra costs? Anyway, I might run this process and it could be cheaper. I'm a bit more result oriented. I'm trying to understand what would bring that advantage over machine learning.
Absolutely, that's also a very very important question. And from my point of view, it allows a broader set of people to use forecasting tools because currently to create these pipelines to use the different libraries to even run those workflows, you need to have certain expertise. You need to begin with to know what's Python and how to run things in Python or R or any other programming language that allows forecasting. So it opened the doors to non-technical people to be able to run these fantastic open source tools, but just with natural language. And also it opens the door for not non-technical interested people in using a forecasting tool just with natural language. It also can help some practitioners or organizations to focus on different aspects of their business or of their roles instead of the forecasting task. No, at the end of the day, a lot of the problems that are being solved in different organizations need forecast, but at the end of the day, they need to do something with those forecasts so they can, instead of on focusing on designing forecasting workflows, they can start or continue focusing on how to use those forecasts to solve different problems. And it can also reduce the time of deployment to production. If you want to create your own workflow, you probably need to spend, I don't know, some days, some weeks, even some months with this Time Copilot. The dream is that you can reduce that to just maybe one day to begin with, but as you can saw in the example I don't know, maybe 5 minutes, but let's see.
Okay, so yeah, sorry, as we have time for one more question. Yes, please.
And if it's right, yeah, this is fine.
Thank you for the interesting talk. I think it's very useful, as you said, for democratizing forecasting.
Might be a bit loud.
Louder. Okay. My question is about one of the points on your slide was no one has cracked it yet, which is definitely true for most research, I guess. But then prior to this talk, I did some experiments with 3D and Plot about automating this workflow with them, and they were very preliminary experiments. And then my intuitions from that was they could do most of this already, like GPT off the bat, Plot off the bat. If you just prompt them well and if you give some feedback, they could probably do all this. But I guess from your talk, there's a bit more to solve. So my question to you is, what would make you say this thing has been cracked? So where do you think we need to focus on if we need to crack this problem? Would it be building benchmarks? In which case, what do these benchmarks have to have? What would be the metric? What are we trying to solve?
I also love that question because I think it shows that the problem hasn't been cracked yet, and we need to start, I think, as a community to think about on those things, how we measure the success of agentic AI for forecasting. What are the metrics that we want that we will be using? What are the benchmarks that we want to use? And I think it's very important because of that. No, in my dreams I wanted to show you some benchmarks on this thing, but I think there aren't benchmarks there. There is no way to compare or objectively compare Time Copilot to against other tools because we haven't decided yet how to do that. So I say that it's cracked yet because of that. We don't know we don't even know how to benchmark this.
Fantastic. Thank you, Azul. Please, everyone, join me in thanking Azul again.
Thank you.